In previous video, we see the Rutherford alpha particle experiment. In Rutherford use gold foil because gold is the most malleable metal, and radium for the alpha source of alpha particles, and one circular screen behind the gold foil. He bombarded alpha particle on the gold foil and found radium inside the lead block and slit of a lead, and he arranged the and performed the experiment. And on the basis of his experiment, he observed the following. First is, most of the alpha particle 99.9% pass through the foil without undergoing any deflection. Second, a few alpha particles deviated through small angles. And third, very few, only 1 in 20,000 were deflected back, that is through an angle greater than 90 degree. So what are the observations of Rutherford alpha particle experiment? Most of the alpha particles, many of the alpha particles passed through the foil without undergoing any deviation, that means passed in the straight line. Second, few alpha particles deviated through small angles, that means they deviate from its original path and form some angle and deviated in another direction. And very few, only 1 in 20,000 bounce back, that means come in the same direction. Now, conclusions of Rutherford alpha particle experiment. On the basis of observation of Rutherford alpha particle experiment, Rutherford gave the following conclusions. First is, most of the space in an atom is empty. Most of the space in an atom is empty because most of the alpha particle pass without any deviation in straight line. Second, there is some positive charged particles present in an atom. A few alpha particles deviated through small angles. That means an alpha particle is positively charged particles, and there is some positive charge present in an atom, so that some positively charged particle, alpha particle, deviated from its path and deviated with some angle. Third is, conclusion is, there is some heavy positive mass in an atom. There is some heavy positive mass in an atom. Third conclusion, there is some heavy positive mass in an atom, so that alpha particle deviated from its original path. Fourth conclusion is, the heavy body present in the atom must be occupying a very, very small volume. From X-ray experiments, it has been found that radius of the atom is of the order of 10 to the power minus 10 meter or angstrom. 1 angstrom is equal to 10 to the power minus 10 meter, while the radius of the nucleus of the order of 10 to the power minus 15 meter. Rutherford discovered nucleus, very small in size, carries positive charge, and in which the entire mass of the atom is concentrated. Rutherford discovered nucleus. Now, on the basis of observation and conclusion, Rutherford gave a nuclear model or atomic model. Following are the points of Rutherford's atomic model. First point of Rutherford's nuclear model or Rutherford atomic model: the positive charge and most of the mass of the atom was densely concentrated in extremely small region. This small portion of the atom was called nucleus by Rutherford. So in this way, Rutherford discovered a nucleus. Second point of Rutherford nuclear model: electrons revolve around nucleus in fixed path and this fixed path is called orbit. This model resembles the solar system, just like the solar system. Third, electrons and the nucleus are held together by electrostatic forces of attraction. So, what are the main points of Rutherford nuclear model? 3 points of Rutherford nuclear model. First is most of the positive charge and most of the mass concentrated in a small region of an atom, and this region was called a nucleus by Rutherford. Second is electrons revolve around nucleus in fixed path, and this fixed path is called orbit. This model resembles the solar system. We can compare this model with a solar system in which different planets moves around the sun, like electrons revolve around the nucleus of an atom in fixed or path, which is called orbit. Third, electrons are and the nucleus are held together by electrostatic forces of attraction. Electrons are negatively charged and the nucleus is positively charged, so electrostatic attraction force work between nucleus and electrons. Now, demerits of Rutherford model. First, he didn't say anything about the stability of an atom. He didn't explain the stability of an atom. How atom is stable, he couldn't explain. Second, energy of different cell. He couldn't explain what are the energies of different cells. Third, electronic configuration of an atom. How electrons are distributed in different orbits. So these are the demerits of Rutherford's atomic model. We can see in the figure a scattering of alpha particle by a single atom and a scattering of alpha particle by group of atoms. In first case, a scattering of alpha particle by a single atom, we can see here this is a single atom considered as spherical, and this is positively charged nucleus, and the alpha particles, the path of alpha particles, we can see some alpha particles deviated and most of the alpha particle pass in a straight line, and very few alpha particle, 1 out of 20,000, bounce back. And in and in second case, we can see a scattering of alpha particles by a group of atoms. In this way, in this figure also we can see that most of the alpha particle pass in a straight line without any deviation, and some alpha particle deviate with some angle, and very few alpha particle, 1 out of 20,000, bounce back, that means return in the same direction. Atomic. Now what are atomic number and mass number? Atomic number is the number of protons present in nucleus of an atom. We can say that number of electrons is also atomic number in a neutral atom. If an atom is in neutral atom, number of protons is equal to number of electrons. So we can define atomic number as it is the number of protons present in an atom or number of electrons present in a neutral atom. A neutral atom. Total number of electrons present in the in neutral atom, hence it is also known as proton number. Atomic number is also known as proton number. Mass number of an element. Mass number of an atom of an element is the sum of number of proton and number of neutron. Mass number is represented by capital A. So capital A is equal to number of proton plus number of neutron. P plus N, and number of proton is equal to Z. Z is atomic number. Atomic number is represented by Z. In here, symbol of an element, Z represents the atomic number of an element, and A represent the atomic mass number of an element, and X is an element. So if we want to represent atomic number and mass number, we can represent in this way. In lower side we can write atomic number, and upper side we can write mass number, and X is an element. So in this way we can represent atomic number and mass number of an element.